Hi, this video is an inverse cosine function. So when we try to deal with functions, for a function to have an inverse, it has to be one-to-one relationship. The graph of cosine clearly is not one because horizontal line test, when you run that, you are going to see that the graph crosses the horizontal line crosses the graph at multiple points. So for the same value of y, you have multiple values of x. However, because of this function being periodic, if we restrict our domain to only this part, then on this interval the graph of cosine is going to be 1-to-1, and we will be able to use that. So we're going to restrict our domain to going from 0 to pi, and the range obviously is going to be from -1 to 1. So then for the inverse cosine, or also known as arccosine, the domain is going to be from -1 to 1, and the range is going to be from 0 to pi. So when we get the value, it has to fall in this interval. This is what the graph of arccosine looks like. So the domain is from -1 to 1, and the range is from 0 to pi. Let's take a look at problems. So the first set of questions, arccosine of square root of 3 over 2. So we need to find the measure of the angle whose cosine is going to be square root of 3 over 2, but it has to fall on the interval from 0 to pi. And that angle is going to be pi over 6. If you know your unit circle, it should be pretty easy. Arccosine of 1/2, same reasoning. What angle has a value of cosine of 1/2? That angle is going to be pi over 3. And then arccosine of negative square root of 2 over 2. The angle, if you want to be between 0 and pi, is going to be 3 pi over 4. So far so good. What do you do when you have arccosine of cosine of 4 pi over 5? So think about this. If you take cosine of 4 pi over 5, you will get some value, and then you take arccosine of that value, you're going to get back the angle. You're going to get back that angle. Well, the angle of 4 pi over 5 is on the interval of 0 to pi, so the answer here is 4 pi over 5. What about arccosine of cosine of pi over 8? Well, take cosine of pi over 8, then do arccosine of that value. You should get back the angle, and the angle should be pi over 8. And this angle here is on the interval from 0 to pi, so pi over 8. This is usually where students start thinking, oh, that sounds pretty easy, just one thing cancels the other and you get the angle. That's not always that simple. Let's take a look at these problems. So we're doing arccosine of cosine of negative pi over 7. So if I look at this angle here, is this angle going to work for me? And the answer is no, it's a negative angle. But we need to be on the interval from 0 to pi. So then we're going to say, okay, let me take a look at the unit circle and see where else I can find an angle like that. So negative pi over 7 is here, right? So we're trying to work with cosine. We want to think about this. We want to find another angle whose cosine will be the same as negative pi over 7. So for that, since cosine is related to the x-coordinate, we're going to go up here. We're going to get this angle. And I think it's pretty easy to see that these two angles here are going to be congruent. So what's the difference here? This angle is negative pi over 7, this angle is positive pi over 7. So our answer is going to be positive pi over 7. Okay. Moving on, example 7. We got arccosine of cosine of negative 4 pi over 3. We'll look at this angle. We're dealing with arccosine. This angle cannot be negative. So that's not going to work. So let's take a look where else we can find an angle that's going to have the same value of cosine. So negative 4 pi over 3 is actually going to end up being in quadrant 2, right? So we are actually in the correct quadrant, because for arccosine we need to have an angle in quadrant 1 or 2. So the only thing we need to do here is find the coterminal angle for that one, which is simply taking 2 pi I'm sorry, taking that angle and adding 2 pi to it, so negative 4 pi over 3 plus 2 pi, and it's going to be 2 pi over 3. That's our value. Okay. And the last example here, arccosine of cosine of 13 pi over 8. So 13 pi over 8 is positive, but the problem is this angle is too big, it exceeds pi. So where exactly is that angle located? Well, negative 13 pi over 8 is going to end up being in quadrant 1. So we're again are going to be good in quadrant 1 because for our cosine our angle needs to be in quadrants 1 or 2. But the angle cannot exceed pi for our cosine. So we have to find the coterminal angle here, and then we'll be done. So what we do is we do 13 pi over 8. I'm sorry, it's going to be 2 pi, right, minus 2 pi minus 13 pi over 8. It's going to give us 3 pi over 8. And the answer here is going to be 3 pi over 8. Okay? Hope this was helpful.